Okay, so range, whoops, flipped back. Range is 16 kilograms, the standard deviation 4.1 kilograms, and the variance is 16.5 kilograms. Is a weight gain of 15 pounds unusual? Why or why not? Okay, so if we think about our mean from the last time, and let me just glance back so we don't have to recalculate it since we've already done it. We found the mean was 1.9 kilograms. Okay, so what we want to do is take x bar, whoops, I keep jumping back, x bar minus 2 times the standard deviation. That's going to be our minimum usual. And then our max usual is going to be x bar plus 2 standard deviations. So 1.9 minus 2 times 4.1. And 1.9 plus 2 times 4.1. So 1.9 minus 2 times 4.1 is negative 6.3. And 1.9 plus 2 times 4.1 is 10.1. Okay. Is a weight gain of 15 pounds unusual? Okay, that would be 6.8 kilograms. And the answer is no, because it falls in this interval. Usual interval. Range rule of thumb. It's not unusual, but it's certainly not supported by the evidence. All right, now the last one I want to do is, let's see, we'll do one more this way, and then we're going to use StatDist to do the last one, is customer waiting times. We have 2 banks, and we're supposed to find the coefficient of variation for each bank so that we can compare them. Okay, so we have Jefferson Valley, and this particular bank, for their weighting, they have a single line. I believe that's the way my bank does. You wait, and then the next teller that opens up, you get to go. Providence has individual lines, so if you get behind somebody who's taking a long time, you get stuck. So I need to find X bar and S for both of these. So let's use the calculator. I'm not going to write the numbers down this time. Clear that, and I want to clear my keystrokes. Okay, now this time I'm going to use 2 columns. So I can go ahead and enter all the data. I'm going to put the Jefferson Valley Bank data in the first column, and then the Providence Bank in the second column. Okay, 6.8, 7.1, 7.3, 7.4, and then 3 7.7s. 7.4, 7.7, 7.7, 7.7. Okay, so we have 10 values. Now I'm going to move to the right, and I'm going to put the other banks, Providence in the second column, 5.4, 5.8, 6.2, 6.7, 7.7, 7.7, 8.5, 9.3, and 10. Okay, so I'm going to do, I want L1. Okay, and what I need to jot down is X bar, okay, is 7.15. And my S is 0.48 if I round it. And this is minutes, so these are minutes. Okay, now let's do it for the other bank. I just go to Stat. I want to choose Calc, so I'm going to move over to the right. And this time I want to enter L2, so I get the second bank. And X bar is 7.15. So it's exactly the same. And our standard deviation is 1.82. So our coefficient of variation for Jefferson is going to be 0.48 divided by 7.15 times 100% to come up with a percent. So 0.48 divided by 7.15 is 6.7%, or 6.71. And for the Providence, we're going to have 1.82 divided by 7.15 times our 100%. So 1.82 divided by 7.15 times 100 at 25.45. Okay, so let's see. All right, so they both have the same mean waiting time, the 7.15 minutes. However, what we notice is there's a lot more variation in Providence Bank. And we can tell that actually by the larger standard deviation as well as the larger percentage. So your chances of waiting longer are greater at Providence than they are at Jefferson Valley. Okay, the last thing I want to do is go to StatDisk and just show you, and I have an older version here, so I'm not sure that I have something, let's see if I can try to move my window up briefly, but anyway. Okay, so what I'm going to do is I'm going to open up a data set. This goes back a couple of editions, and just show you how you would do this. Let's just go with female health. And let's just go with the age column. So I'm going to copy column 1 Okay, now what I want to do, I'm going to data, and under data we have descriptive statistics. Okay, and I want you to do column 1, and I'm going to evaluate it. And let me move it down here where you can see it better. So you can see, notice what's happened when we evaluate that one column. We get the mean, the median, the mid-range, variance, standard deviation, the range. All of those are given to us and we can print them out. So, and you have a print there. So it's really a quick way. Anytime the book refers you to a data set in the book, if you've downloaded the new stat disk for this edition of the textbook, you can go to stat disk and do it. So anytime you're using a large data set from the back of the book, think stat disk, and you can go ahead and use stat disk to do the problem. And that way you don't have to type all those individual numbers in.